Good morning, everybody. So today we're going to look at standard form of a line. Don't pay attention up here to Throwback Thursday. This is actually Throwback Tuesday. I don't know why I wrote that on the notes. I guess it was Thursday when I was working on this. But a couple things to recall, probably from Math 8, but a little bit from yesterday's assignment as well. First one is, where can we find the y-intercept on a graph? Well, what we know is that the y-intercept is when the function crosses the y-axis, or when x equals 0. Okay, so something that looks like this. If this is our graph, this is our x, this is our y, and let's say our function crosses the graph like here and here. Okay, so it's where it crosses that y-axis, right? And it would be right there. Okay, so that's a y-intercept because it touches the y-axis at that point. And then it says, what is the x value of the ordered pair that describes the location of the intercept? So if you were to write this one as an ordered pair, it would be 0, 3, right? Because that's the y value. And that's basically what it says. Every single time if you're looking for the y-intercept, it'll be 0, a number, right? That's the y-intercept. And on the flip side, where can we find the x-intercept on a graph? What is the y value of the ordered pair that describes the location of the x-intercept? So the x-intercept is where the function crosses the x-axis, or when y equals 0. So in this one, in an ordered pair, it'd be some number, 0. So again, similar idea. Okay, we graph a function on a line, and it crosses the x-axis, let's say right here. Okay, so that would be that point. So if it's, let's say, 2, so then that point would be 2, 0, right? So some number and then 0. Some number and then 0. Okay, find the x and y intercepts of the following graphs. So what we're going to do is we're going to label them as ordered pairs. So as you can see, it crosses the y-axis here at 4, so that would be the y-intercept, 0, 4. And it crosses the x-axis here at 1, so that would be 1, 0. All right, example 2, crosses here and here. This is the x-axis at 3, so x-intercept is 3, 0. And then crosses the y-axis at -3, so this would be 0, -3. Notice how they flip, right? X and y's flip here. Okay, let's continue here. So x-intercept crosses here at, we'll say, -1. Okay, and where does it touch this y-axis? Oh, it doesn't, right? So there is no y-intercept in this example. Okay, how about this one? Okay, this one crosses the x-axis. Actually, it's sitting right on the x-axis, so this would be infinite. Okay, and where's the y-intercept? Well, even though it's on the y-axis, or on the x-axis, it crosses right here. Like it crosses this red line right there where y equals 0. So this actual y-intercept is at the origin, 0, 0. Okay, so previously you've only been able to graph an equation using slope-intercept form, which is y equals mx plus b. Okay, that's what we did yesterday. However, you can also graph an equation that is in standard form, ax plus by equals c. We're using x and y-intercepts, where a, b, and c are known as integers. Okay, so they're whole numbers and non-zero. Okay, it says examples, find the intercepts and graph the following equations. All right, so as you can see, y is not by itself now. You have a 2x and a 3 and a 6. So there's a way that you can actually graph it, even if it's in standard form, unlike intercept form. So what we're going to do is we're going to do 2 steps. Number 1, we're going to plug in 0 for x, and then solve for y. And number 2, we're going to do the opposite of that. We're going to plug in 0 for y, solve for x. Okay, so there's 2 steps to finding the intercepts. So let's go ahead and do step 1. It is a little bit of work, but that's okay. So we're going to plug in 0 for x. So now it becomes 2 times 0 plus 3y equals 6. Anything times 0 is just 0, so this is just 3y equals 6. Divide by 3, divide by 3, y equals 2. Okay, so that means our y-intercept is at 2. All right, so then the second one, do the same thing, only now we're plugging it in for y. So 2x plus 3 times 0 equals 6. 2x equals 6. Divide by 2, x equals 3. So here's our other intercept on the x-axis. Okay, and anytime you're working with standard form, I'm okay if you just do the two dots instead of 3. If you're in intercept form, you need to have 3 dots. Okay, so there's our line. All right, same thing here. Okay, now step 1, I'm going to plug in 0 for x. Negative 2y equals 10. Divide by negative 2. Y equals negative 5. So negative 5 on the y-axis. Okay, and then do the same thing where you plug in 0 for y. Cancels out, so you have x equals 10. Okay, there you go. Simple as that. All right. Sometimes you may have to rearrange the equation to get it to standard form. So if it asks what are the intercepts, it might be easiest just to rearrange it in intercept form and then work it through that way. So we're going to do that with these next ones. It's kind of like what we've done before. So again, we're going to rearrange into standard form. So that means we want a, x, and by. So essentially we want x and y on the same side. So notice here we do not have that. So we're going to add 7 to the other side. Or, better yet, let's subtract 3y from both sides. Okay. So now I have negative 7, because this cancels, equals 2x minus 3y. Okay, done. The other thing that we didn't really write up here, but it says non-zero, but a should not be negative. Okay, so the value out in front of x should not be negative. If it's negative, you have to take it to the other side, or divide everything by negative 1. Okay, let's try number 2 here, or number 8. So x and y are on the other side. X is positive on this side, on the left. So I'm going to keep it on this left. I'm going to subtract 9. So I have 4x equals negative y minus 9. Okay, now I'm going to add y to both sides to get x and y on the same side. And I have 4x plus y equals negative 9. Done. X and y are on the same side. X is positive. They're all whole numbers. Fantastic. Okay, let's try this one. Okay, so you have x on this side. So we're going to subtract this 5. So now I have 1/2 y minus 5 equals 4x. Okay, I have 1/2 y minus 5, so I'm going to subtract it because it's a positive from both sides. Okay, but notice now we have a fraction. All right, so here's the one key. We want to get rid of that fraction. So to do so, we're going to multiply everything in here by the denominator. Okay, so we have 2 on the bottom. So we're going to multiply everything in here by 2. So we have negative 10 equals 8x. And half of 2 is just 1, and it's negative. So we have a negative y. And now notice we all have whole numbers. X is positive. Okay, and x and y are on the same side. So you're good. Okay, real world applications here. Last thing, the travel club, in an effort to make money for their spring break trip, is running a concession at the basketball game. They sell hot dogs for $1 and sodas for 50 cents. At the end of the night, they have collected $200. Let X represent the number of hot dogs sold and Y represent the number of sodas sold. Write an equation to represent the number of hot dogs and sodas sold. What is the maximum number of hot dogs or sodas that were sold to collect $200? All right, so they sell hot dogs for $1, sodas for 50 cents. So one hot dog. So let me state this first. X is going to be hot dogs, hot dog, hot dog. Y is going to be sodas. Okay, so 1x plus 0.50y equals 200. Write an equation to represent the number of hot dogs and soda coolers. Okay, it says what is the maximum number of hot dogs or sodas that were sold to collect 200? Okay, well, let's assume if we're talking about maximum, then we're thinking, okay, well, what's the maximum number of hot dogs without selling sodas? So let's plug in a 0 here for sodas. So I have 1x plus 0.50 and then 0 sodas. Okay, so that cancels out. So we have x equals 200 hot dogs. That's the maximum number of hot dogs. So maximum. Or we have 1 times 0, which is 0, plus 0.50y equals 200. Okay, this is 0, so we have 0.50y equals 200, divide by 0.5, divide by 0.5, y equals 400. So 400 sodas. Okay, so if we sold no hot dogs, we could sell 400 sodas and make $200. Or if we sold no sodas, we could sell 200 hot dogs and still make $200. All right, last one. You decide to open a coffee shop where you offer both coffee and tea. You decide to sell coffee at a cost of $2.50 per cup and $2.50 per coffee, and tea for $1.75. If you made $1,002.75 your first day, how many cups of coffee and tea were sold? Okay, what it means by that is what is the maximum? Okay, so what we would do here is you could plug in 0, so 2.50 times 0 plus 1.75 t. Okay, pull up some decimals here. So 1,002.75 divided by 1.75. Okay, so cups of tea would be 573 or less. All right, let's do it the other way for coffee. Plug in a 0. Okay, so this would be cancel out. 2.50x equals 1,002.75. Divide by 250. Gives you 401 cups. Okay. So we could say less than 402 or less than or equal to 401 cups. Okay. So that's how you work through some word problems. You set it up like a standard form. Okay, and then go ahead and solve. You have an exit ticket for homework tonight. I want you to go ahead and do that. Make sure at the word problem here it says if you bought 30 burgers, so you're going to plug in 30, right? Okay, let me know if you have any questions. I'll see you guys after.